Okay, I think everybody should be here now. I welcome you to this webinar, Getting Started from Data to Graph Visualization. My name is Benjamin Niedermann. I'm a software developer at Yworks and a member of the Layout Algorithms team. And I'm very happy to welcome you to the second episode of this series of webinars on the art of graph visualization. In this series, I present and show how to create not only beautiful graph visualizations, but also meaningful and useful graph visualizations. And with meaningful and useful graph visualizations, I mean visualizations that you can actually use to gain new information and new insights from your connected data. In the last episode, the first episode of this series of webinars, I gave a big picture on the art of graph visualizations and described 5 important aspects that you need to consider for this. One moment. Oh. So these 5 aspects are the problem setting, the analysis, the layout, the styling, and the interaction. So what I've done in the last episode, I just described these aspects that you need to consider for graph visualizations, describing them on a high level, giving you some examples. In today's webinar, I would like to consider one of these aspects more in detail, namely considering the problem setting. As I argued in the last webinar, it's important to consider the problem setting in a greater detail, investing also a lot of time thinking about what kind of questions you would like to solve with your graph visualizations. So what I did, I said, okay, there are basically two phases, namely the preparation phase where you need to think about your graph visualization. And then there's a creation phase where you can actually implement your ideas. So for example, by using software kits or also just by using tools. And today I would like to go to the problem setting and have a look at this problem setting more in detail. And when you think about a graph visualization, you need to answer some of the questions that I show you in order to get a good graph visualization that has also a meaningful and useful, or which is also meaningful and useful. So one very important question that you need to solve is what question should be answered with a visualization, or put differently, what kind of tasks should be solved with a graph visualization. So for example, if you have some kind of metro system and you would like to show the shortest path between 2 stations, then you need to select an appropriate layout for this graph visualization in order that the people can actually conduct these tasks in this visualization. Then another important question that you need to solve is, which you can consider is, are there already similar visualizations? So it's important that you don't reinvent the wheel. Typically, there are many visualizations out there that already solve similar problems. And of course, it's a good idea to have a look at these visualizations and to see whether you can get some ideas from them. The next question is, what is the underlying graph structure? And this is a really important question. And in this episode of this series, I will basically focus on this question. So what are the nodes? What are the edges? What are the attributes of the nodes? And what are, for example, the labels of the nodes and the edges? This is a question that you should answer before you start creating your graph visualization. And then finally, there is also the question where and how the visualization is deployed. And here I mean with deployed, not only the technical deployed or the technical term deployed, but also which type of users will use this graph visualization and in which kind of environment is this visualization embedded. So I don't want to do this on a theoretical basis today, but I would like to use a very concrete example. So I thought about an example that we all can relate to, namely a music database. So a colleague of mine came to me and said, okay, there's a really large music database that you may use for this webinar. And I think I can use this example through all subsequent episodes as well. This music database is called Discogs. And it's basically a Wikipedia-like database on audio records or recordings. And so the idea is that the users can basically edit and insert new entries. So for example, for releases, but also for artists and labels, and connect these entries. So basically it is a really large graph structure which is built in this data structure, in this database. And besides that, it also includes a marketplace so that the users can actually trade their recordings with each other's. And yeah, basically, it's not only a database where you can look up releases, but you can also trade releases. And as I already said, this is a really large database. It has more than 600,000 users and over 16 million releases and over 8 million artists and over 2 million labels. So just by looking at these numbers, it should be clear that it's not a good idea to visualize the entire database by a really large graph where each entity is basically represented by a node or an edge. So this would be much too large. Basically, what you would get is a really large hairball, which you probably can't use to solve certain questions. So the idea is that you take another way and you don't start with the data, but you start with a question what you would like to solve. And the idea is that during the webinars, I will consider graph visualizations that you could use as a component for a music explorer. And now the question is, what kind of graph visualizations? Or put differently, what type of questions would we like to answer on this music database? And so what I've done is that I've just asked my colleagues what they would like to know from the music database. And one of the colleagues, or actually several colleagues, said it would be nice to start with the favorites, with their personal favorites, so maybe some album, and then to explore the music going from these favorites. Another colleague said, okay, it would be really nice to see where the hotspots, the geographical hotspots are for music production. So where are the large companies placed on the world map? It would be nice to have some kind of world map and some kind of relations between these companies. The next question was, okay, we often consider fraud detection in graph visualization, and this database also contains a marketplace, so it's very likely that we can also detect fraud in this database, and can we also visualize this fraud? This is also a very interesting question. Another colleague said, okay, I would like to learn about the history of artists. So just to see how an artist has developed, with whom he has or she has collaborated and has published releases. Another question would be that someone has a large collection and would like to complete this collection and would like to see which releases maybe are still missing and which releases are, for example, available in the marketplace. And then there's also the question how the genres of the music are related to each other. So it's a really large database, and it's the releases are categorized in genres. And now it would be interesting to know how they relate to each other and whether they relate to each other. And finally, there was also the question, which songs are covered in which genres. So for example, there's this very famous and popular song Last Christmas, and it has been covered basically in every genre. And it would be interesting to know more connections about this, this covering of songs. And the question here is, can we visualize this with graph visualization such that we can actually solve or answer this question. So now we have 7 questions that we could consider. And what I've done then is that I just had a look at the data to see whether we can actually solve these questions. So it's not clear at the moment whether the database is sufficient in the sense that we can actually answer these questions. So we need to consider the database and its structure. So the question is what data is given. And the nice thing is that this database is publicly available. So it means that it has an API that you can call and you can basically query the entries of this database. And you can do this for free. And so what I've done then is I had a look at the description of the API and had a look at the entries of the database. However, it was a bit difficult to actually see how these entries are connected to each other. So there is no real schema of the database. And I would like to have some schema, of course, as a graph visualization. So what I've done then is that I started creating my own schema visualization on the database using, for example, a graph editor, and I used Wired Live. So I can just show you this. So this is the last session. So what I've done basically is that I went to the homepage and to the documentation, and then I identified these most important concepts in the database, and then I thought about the connections, how they are actually connected. So for example, there's this concept of the artist, and the artist has a name, a real name, a profile, and images, and so on. And of course, an artist may also be connected to a group, so to a music group. And then the artists may also release some songs or some recordings, and this is called a release. So there's a master release, which is basically the original release, and then maybe there are some other releases based on this master release. And continuing this, I've just created this little graph drawing, which then helped me already to see whether I may answer these questions that I've just mentioned before. So what I've done then is, maybe first I should note that these edges are just associations. Typically what you normally do if you create such visualizations, you also write cardinalities to these edges, but I refrained from this in order to keep it simple. But the entire visualization now helps you to understand the database better. And maybe what I also would like to mention is at this point that I've divided this visualization in 2 parts, namely the music model, and basically we will work on this music model, but there's also the platform with the user and the marketplace, and maybe the concepts of what the user would like to trade, so what he has or what he would like to buy. So this visualization basically gives us the possibility now to decide which of these questions we can actually solve using graph visualizations. And this is also an important point that you should take with you from this webinar, is that you should try to understand the structure of your data in order to create your graph visualization. And now I would like to go through these questions and see whether we can solve them using the database and answer them using the database, and also describe how I would create a graph visualization. And as I already said, we are still in the planning phase, so all what you will see now are still sketches, but not graph visualizations that are completely finished. So let's start with the first question. Starting with my favorites, I would like to explore the music. And in order to answer or to see whether we can solve this task with a graph visualization, we should also better understand what is meant. So what I can do here is I can go to the Discog page, and here I've just went to the song Yellow Submarine of the Beatles. And what you now can do is you can explore this web page by, for example, clicking here on the Beatles. And then from the Beatles, you can continue going to maybe to one of the members, to John Lennon, and then you can see what types of releases John Lennon has, and so on. So basically what you can do is just by going from link to link, you can explore the music database. And the idea is now that we will try to do this not by just showing a single page, but it would be nice if we could do this using a graph visualization. And here the idea is that we first have a look at existing graph visualizations to gain some ideas. And then after that, we can basically talk about the graph structure. So we can talk about what is a node in our graph visualization and what is an edge in our graph visualization. And then based on this, we can also try to sketch some ideas. But here I would like to remark and point out that these sketches are not meant to be the final graph visualization, but they should more describe some ideas how we basically project the data entities on the graph elements. So let's have a look at an existing visualization. For example, here I have this Wonderlands. I think I've already showed this in the last episode. Here the idea is that we are given a graph which shows criminal cases. And so we have people here and they have some connection. And actually, this is not the entire graph, but we only see a small part of the graph. And what we can now do is that we can take this lens and hover over the nodes, and we can then decide which part of the graph we would like to extend. And basically, this is the very same idea for this music explorer. We just want to explore the songs and artists and groups. So we just have different types of nodes. So for example, this could be an artist, and this could be the group of the artist, and so on. So this gives us already some idea how such a visualization could look like and how it could work. In our case, we now need to think about how to map the data entities to graph elements. And we have the following data entities that are interesting for us for this use case. So we don't need to consider all these data entities that I've shown you before in the graph visualization. So for example, we have here this album or release, I called this in the last graph visualization, the artist and the group. And obviously we would like to have them as nodes. And then they have, for example, tracks and a year, and we would like to use them as attributes and so on. And this looks a bit technical and maybe also a bit boring if you want to create a graph visualization, but this is a really important part of this process where you decide which part of the data is mapped on which part of the graph. And here, for example, for the edges, I could also decide, okay, an edge X to Y means that the artist X is a member of a group Y, and group X has released album Y, means that there's also an edge from X to Y. As these tables look really boring and don't convey the idea very well, I also introduced these sketches here, which basically shows the table again. So, but using an example. Here you have these artists, for example, here Paul McCartney and John Lennon, and then you have also this group, the Beatles, and here what you see here is that both also were members of the Lennon-McCartney band. And then we have other nodes, also the other members of the Beatles and so on. So basically this describes already the table, and gives you the idea. And now we could think about how to implement this, for example, also using such techniques as I've just shown you with this lens techniques, where you can basically click on one node and then the graph is extended at this node. So now I would like to go to the next example, and I will go through these examples, and for each example I will point out some other aspects. So I will not have a detailed look at each of these tables, for example, but I will only point out the most important aspects. So the next thing that someone asked is that she would like to learn about the history of artists. And then I thought about how could I do this, and what kind of data do I need to visualize this? And then another colleague came to me and told me, hey, we already have some kind of visualization that basically does this. You should have a look at this. And this is here, this Marvel cinematic universe, and maybe you already know this visualization. So we can click on this, and this is actually an interactive visualization. And basically, it also gives you an idea how our visualization could look like. Because what it shows is basically the Marvel universe, so all protagonists of the Marvel universe. And then, so for example, here we have here Iron Man. And then what we also have is the movies in which Iron Man occurs. So Iron Man occurs, of course, in Iron Man and Iron Man 2, but he also occurs in the Avengers, for example. And what we see is that here we also plot the history, so basically the years. And if we now think about our use case, this is basically the very same problem here. So what we could say is that the protagonists are not, or these nodes are not the protagonists, but they are artists. So I could say, okay, this is maybe John Lennon, and here we have Paul McCartney, and then they've joined or released some song, and that we could also visualize with these intermediate nodes. So basically what we get here at this point is already a visualization that tells us how this visualization that we are looking for could look like. So based on this idea, I can now have a look at the graph structure. And here the idea is, okay, we have some artists and we have some albums, and these should be the nodes. And the idea is that these albums should be these large intermediate nodes. And then we could visualize this correspondingly. And here, sometimes it makes really sense to just make a mock-up using existing visualizations, annotating them to just verify whether the idea could work out. Here, for example, we say, okay, these are the original band members, and then there's the first album, and then this could be a further member who joins the band, and then there's the second album. And so we just used this existing graph visualization in order to see whether our ideas worked out. Another colleague said, okay, I would like to complete my collection. And this was also a bit more difficult to find out how you could visualize this, actually. Basically, the most important observation was that someone who collects, for example, audio records would like to categorize these audio records so that you get some kind of hierarchical structure. Here you can already see the basic idea. We have here a band, and then we have some kind of releases, and a format, for example, whether it's a CD or whether it's a cassette, and so on, and then the year, and basically the leaf notes are the audio records. And now we could say, okay, the leaf notes of this tree structure are the actual records that you can buy, and this we could use as a visualization. Here in this table, it's a bit more difficult to basically write this down. Here it's really nice to just have a graph visualization showing this. Of course, we had also a look at existing visualizations, and here there are many different types of visualizations that you could use as a basis. Here I just had a look at the Tree of Life, which also basically categorizes the data. Just want to show you this small demo here. It takes some time for loading because it's a really large graph, and I will just restrict it to a smaller graph, let's say to viruses. And the idea is that this graph, we have some main category. This could be, for example, the band, the music group that we would like to collect. And then we have subcategories like the format, the album, the year, and so on. And the leaf notes could be then the audio recordings. And then we could have a similar visualization using a tree visualization. So again, we can use such visualizations, such existing visualizations, to get some ideas how we could visualize our own data. Here I also would like to mention, it's always a big question how to create these sketches and mockups. As I already showed you, you could do this, for example, in Wired Live, just by clicking these graphs together. You could also do this by just creating a mockup by placing or by annotating an existing visualization. And here I would like to show you a different way to do this. One moment. And what you can see here is a Jupyter Notes notebook that basically queries the API. You don't need to understand the full code, but I just give you some basic ideas. Basically, what we do is that we connect to the database, and then we read some of the entries from the database. So we read really only a restricted number of entries, and then we, based on this number of entries, or based on this set of entries, we create a small graph. This is basically done here. You don't need to consider the details. But the idea is that based on this data dumps, on this small data dump, we get already some realistic data set that we can actually use to test whether our visualization or the mapping from data to graph elements could work out. And what I've done here is now that I've just executed this. Here I'm using Wi-File's Jupyter Wi-File's graph for Jupyter, so a Python extension that you can use for Jupyter notebooks. And then when I execute this, I get actually this graph layout here. And then what I've also done is to further create this, or to further extend and elaborate on this sketch and mockup, I just loaded it in Wired Live. Here I need to accept this, and then I started editing on this data set. This is also a very nice way to get to know your data, because you already work a bit on your data by querying it and learning about the data structures and the characteristics, but you can do this in a very small kind of playground, seeing whether this mapping of your data to the graph already works. So the next example is also interesting for considering how to create such mockups and sketches. Here the question was, how are the music genres are related to each other? And if you recall how the graph structure or how the database is built up, there are connections between genres and styles. I can show you this by just zooming to this diagram here. Here you can see that the genre has some connection to some styles, and this means basically that it could be possible that two genres have styles in common. And this would be an interesting question to know and also interesting to further analyze. One moment, I need to go back to this. And here you can see what we've done then. We just had a first look at the existing visualization to see what kind of ideas are already out there. So here we had the look at the so we just did some image search in Google. This is also a typical way to find existing visualizations for this. So I just used as a search term, I think, musical genres and then graph visualization or network visualization. And then I found this example, which connects the genres with some artists and showing you the connections. And a similar visualization we would like also to have for our data, but we only would like to consider the genres and the styles, as I argued before. So the idea is that we just use the genres as nodes, and then we say that there's an edge between two genres if they share some styles. And the idea is now that we may introduce an attribute, namely the thickness of the edges, in order to express how many styles they have in common. And again, this is only a sketch and mock-up. It should not be the entire graph visualization. You could also introduce, for example, interaction and further techniques, but it should already give you an idea where we could go to. Here, a small remark how we have created this graph visualization. Another way to do small experiments on the data is just to, one moment, it's not loading. That's not a problem. It's here. It's already loaded. And you can just use the playground, so for example, of Y-files to, or Y-works, to basically visualize some of your data, again, just experimenting with this. You can access this playground, for example, on your own. This link should be also sent into the chat, but you can also find this on our homepage. If you go to the examples page, to the playground page and to the examples, then you find here this entry-weighted relations webinar, and then this example is loaded. And the idea was that I just used a data dump of the database to extract these relations between the two genres. For this, I used a Python script and extracted from this basically here this statistic, which is now basically a JavaScript object. And then I used Y-files for HTML to further create the graph. So if I run this code, I basically get the visualization from before. There are some differences in the styling, but basically it's the same visualization. And I don't want to go into the details. I may go into the details in later episodes, but basically what I do is that I create a graph based on this data, on these entries here. And this graph basically consists of nodes where each genre is a node. And then here it's basically this one entry describes an edge. And then I also do some styling and then I get this graph here. So if you would like to see this example in more or in greater detail, you're welcome to just go to the playground and play around with this. But later in the later episodes, I will also show some other examples in the playground by actually programming them. So if you're interested also in these topics. So another question was then, where are the hotspots of the music production? And this was also a quite interesting question, because now we get a further information level on our drawing canvas, namely the world map, for example. So we get some geographic coordinates that we would like to express. And here, what we did to find existing visualizations, we again just had a look using some kind of databases for geographic visualizations. And this is, of course, also a typical way to find existing graph visualizations that could give you some ideas how you could visualize the data. Here, this is a database for geospatial network visualizations, which lists a lot of research papers. And the nice feature is here that you basically directly get the images of these papers, and you can scroll through this database and just see how typically graph or spatial network graphs are and how spatial network data is typically visualized. And what we can see here by just scrolling down the homepage is that, for example, it's very typical that the nodes are fixed on the map and only the edges are routed. And this is a very typical way. And this is also basically the idea how we would like to answer this question. So thinking about our problem, what we could do is that we could introduce for each company a node, and the idea is that the location of the company are already the coordinates on the world map. And then the edges would be that two companies are connected by an edge if they share artists. And again, similar to the previous example, the idea would be that the number of shared artists express or are expressed by the thickness of the edge. This could be some idea how we could visualize this. And here I just used a very simple vector graphic program to make this sketch to see whether it could work out. So it's not based on realistic data. This is just, it just came up with this visualization to basically illustrate how we could interpret the graph structure. And here, I think the most important question will be about the routing of the edges. So probably there will be many more edges than in this drawing. And then we need to think about how to route these edges. And this is a topic that will be, for example, also discussed in the next episode of this webinar. So then this is the second last question that came up when I asked my colleagues. And here the idea is, okay, this database has also a marketplace, and probably there's also some kind of fraud, and can we visualize this fraud? And it turned out that when we had a look at the database, it's not that easy, because the database does not offer all the data that we need. So this is basically a use case that could be interesting for the provider of this database, who probably has also data on the users and their email or on their discussions, to see whether they, for example, sell their recordings via the platform and not using other ways. But still, I think fraud detection is a very interesting example that could be also interesting for your use cases. So I decided, okay, I would like to have a short look at the fraud detection cases. And here I would like to point out also an existing visualization that you can see on our homepage. in our collection of demos. So I just go there. And here you have you get an idea of how fraud detection could look like. Here the idea is that we typically this fraud detection or these frauds are expressed by rings. So one moment. So like this, here we have one orange ring, and this is called a fraud ring. So typically this is an indicator for that there is something going on that shouldn't go on. And the idea is that you have several users that share the same contact information for buying products, for example, of a bank. And this builds then these rings. And what you can see here is if you change the time when we basically query the database, at some point, I need to make it a bit smaller. At some point, this ring completely disappears, and this is a very typical pattern for fraud. So typically the person creates several accounts using similar contact information and buys some products, and then at some point the person just vanishes with some money that doesn't belong, or without repaying the credits, for example. And this is a typical way how to visualize fraud detection. So using these kind of organic layouts and then visualizing these rings and then having this interactive way to basically see how the network changes over time. And of course, in our use case, we also could think about this kind of visualization where we have just users and we have maybe some kind of communication between the users and also some kind of trading between the recordings. And then we could also visualize this in a similar way. So here we used for the mockup just an example from our demos and annotated this with these red circles just to again to show how this could look like. And now to the last example. This is actually a very short example. Here the question is which songs are covered in which genres, and here it would be important that you actually have this information when a song is covered by another song. And it turned out when we had a close look at the database that the data in this database is not sufficient to solve this task. You could use some kind of heuristics to find songs that cover other songs, but this will be probably not very accurate. So we decided, okay, this question cannot be solved using the database that we are given. So we cannot create a graph visualization based on our database. And this, of course, can also sometimes happen that you just have a question and but your data is not sufficient to answer this question. Then it won't be possible to create a graph visualization that will answer this question, of course. So this gave you an overview on how to tackle these kind of questions that you would like to solve, for example, for graph with your graph visualizations. I gave you a really concrete examples in order to show you how to proceed with this and how to tackle these kind of problems. So by looking at existing graph visualizations and then by thinking about the graph structure, so about the mapping, how is the data mapped to the graph structure. And with this, you get already some ideas how the graph visualization could look like and what kind of requirements you need to fulfill. Another thing that you should think of is how will the visualization be deployed. And as I already said, with deployed, I don't mean only the technical deployment, but basically also how it is used, for example. So in our case, with this Music Explorer, probably we would like to use a website. And this already implies, gives us some implications, namely, for example, that we have some restricted transmission rate between our server and the client. So we need to somehow restrict our data. We probably cannot show large graphs at one click, but we need to incrementally create these graph visualizations in order to transfer the data, for example, step by step. So these are implications you need to think of course, and this will also influence the graph visualization that you create. In our use case, it's really pays off probably to use an interactive application. So for example, if you think about this, exploring the favorites or exploring the music database, starting with the favorites, I've already showed you some solution, how it could look like, and here we have some interactivity. Here I would like to say that you should use interactivity only if it is reasonable to answer these questions or to support the user with the tasks the user would like to solve on the data. And then to find a good way for these interactions. And there will be an entire webinar on this, which will be about the interactions or how to create graph visualizations with interactions. Then in our use case, it's also important to mention that the users are probably not graph experts. So they probably don't know any term about graphs. So it should be really intuitive, this graph visualization. So in our use case, you should use simple concepts. Depending on your use case, you will sometimes also have some experts that can also spend some time to basically learn the system that you have built or the graph visualization that you built. Then you can basically also use more complex concepts. But in our use case, we should really think about simple visualization concepts. Further, we have, of course, a restricted view. We have only maybe a small screen, and so we also should think about filtering information and introducing different level of details just to show not all information at once, but so that the user can actually also decide on which type of information and how much information is shown. And of course, maybe here in our use case, we could think about integrating this into an existing system. And this basically is also a technical requirement often, where you also need to think about how to do this from a technical point of view, and then also satisfying the requirements of the existing system. So there are probably many more things that you should think about. And this, of course, depends very much on the use cases. But I think it already gives you some ideas what to think about when thinking about the problem setting. And with this, I would like to come to the conclusion of this webinar. So in this webinar, we had a clear, detailed look at the problem setting. In the next webinars, we have a look at, in the next webinar, will have a look at the analysis and the layout of the data. And then there will be also webinars about the styling and interaction. In today's webinar, you've learned that it's really important to think about the problem setting and that you can do this systematically. So for example, first identify the tasks and questions that you would like to solve with your graph visualization. Then try to understand your data. So in my case, I just try to visualize the schema of the database. Then identify the graph structure. So the idea is here, create a mapping between the data and the graph. So create or decide what is a node in your graph and what is an edge in your graph and what are the attributes in your graphs. And then a next step is also often very helpful step is to create sketches and mock-ups and do some small experiments, for example, using Jupyter by extracting data and then see whether this already can work out. And then this already gives you some kind of information. And the last thing is that you also should think about the deployment, how in which kind of environment is this visualization used. And this gives you basically good information and a good foundation for the graph visualization. And you should try to invest here some time, because otherwise, if you make here some mistake, it could happen that at the end you have invested a lot of time in the implementation of the graph visualization, and it does not work out because there was some mistake in the decision made in the preparation phase. Yeah, and in the next webinars, I then will go to the creation phase, where it's really about creating graph visualizations. And there I will give you more details about how implement this these kind of graph visualizations in practice. Finally, I would like to note that all the tools that you've seen today, you can also use on your own, and you can play around with this. It's also helpful to just learn how to tackle these problems by just considering small examples. And you can find all these tools also by just going on our homepage. And with this, I would like to wrap up the main part of this webinar and go to the question session, where you now can ask a question, and I will try to answer them. So I will first have a look at the chat, and then I will see whether I can answer these questions. So the first question is, how much time do I need to invest for planning a graph visualization? And actually, this is, of course, a bit difficult to answer, because this depends very much on your use case. Sometimes your use case is, for example, small and very well known. So, for example, you would like to visualize some kind of class structure of your software, and then basically you already know all requirements, and then the idea is clear. So then planning is probably very simple. If you have some kind of problem like here with this music database that you don't know in advance, then it might be really helpful to think about this and invest some time, as I already said before. Could you supply some additional resources about the best types of data sources for working with your tools? Yeah, I think we can come up with these additional resources, or we can do this. But I think we'll do this via chat, or we send you some kind of resources, or we just link them in YouTube. But still, there are many things that you can have a look at our homepage, for example. So I've showed you many of these demos, for example, that you can also just explore on your own and see what kind of layouts are there, and how to configure them, and also where to use them. So there are many different also blog articles that you can have a look at. And there's also a comment that relates to this question. I think maybe I've also misunderstood the question a bit. So the question was, could you supply some additional resources about the best types of data sources for working with your tools? And yeah, maybe at this point I should also mention that there is no specific type of data source that you need to use in order to use our tools, but you can basically use for example, graph databases, but also JSON, XML, and so on, if you use our library, for example, for developing your graph visualization. Because what you basically do is you take your data and you translate this data into a graph structure by directly mapping this. And I probably will also show this in the subsequent episodes, how to do this exemplarily. Let's have a look whether there's another question. Then there's a question that I have a large data set that is difficult to handle. How would you handle this? So yeah, this basically also the example of the webinar already is such an example. We have such a large data set, and of course you can't have a look at the entire data set to see whether your graph visualization works or how to do this. And basically, what I would do is basically what I've also presented in the webinar. I would start by seeing whether I can understand the structure of this data set and then decide whether based on the structure I can actually solve the task that I would like to solve. And then I would also for such small experiments where I just try to find out how to work with this, I would just narrow down the data set and to a reasonable size. So for example, because then you can check whether this works out or not. There's a further question. Where do moving graphs and animated graphs make sense? I believe so. Animation, you can add another layer of visualization, right? Yes. So moving graphs or animated graphs. Here you can basically. So one thing of animation is that you can visualize the change of data over time. For example, if you think about this example with the fraud detection, there we have this possibility to change the time window. And what we would like to have is that if you move this time window continuously, then it's important that a change of the graph is also done continuously. So for example, using animations. So this is an example where to use. There's still some typing. Yeah, so there's also a comment by another colleague of mine that about the animation question, and yeah, it's about basically also telling the story. So sometimes animation can help to tell you this, to tell a certain story, as I said, for the fraud detection, and especially morphing is maybe a good metaphor to show transitions between elements. Here's another question. I'm just reading it. One moment. So basically, the question is about y-AD and using analyzing approaches. So basically, y-AD is a graph drawing editor that you also can use, of course, to analyze things. But I think the main purpose of this is to also demonstrate the capabilities. But if you use, for example, Y files as a programmer, you can basically combine all these features with each other. So here the idea is, okay, in y-AD we show them how to use them also separately, but as a programmer, it's really easy using the Y files SDK to combine such features. Okay, I think this was the last question. And with this, I would like to wrap up the webinar, and I wish you happy DICOM.